Imagine our planet billions of years ago. It's a very different place than what we know today. Instead of 7 continents separated by vast oceans, there's just one massive landmass. This giant supercontinent, surrounded by a single global ocean, is all the land there is. This early Earth is a hot, volatile world. Volcanoes erupt, spewing lava and ash into the atmosphere. The air is thick with carbon dioxide and other gases. It's a hostile environment, but it's here, on this single landmass, that the incredible journey of life on Earth begins. The Earth's crust is not a solid, unmoving shell. Instead, it's a dynamic and ever-changing layer that plays a crucial role in shaping our planet. It's more like a giant jigsaw puzzle, made up of massive pieces called tectonic plates. These plates fit together in a complex and intricate pattern, constantly interacting with one another. These plates are constantly moving, driven by the heat from the Earth's core. This heat creates convection currents in the mantle, which act like a conveyor belt, pushing and pulling the plates in different directions. It's a slow process, but over millions of years, these tiny movements add up, reshaping the planet's surface in dramatic ways. The continents we see today were once part of a supercontinent called Pangea, which broke apart and drifted to their current positions. There are 3 main types of plate boundaries: divergent, convergent, and transform. Each type of boundary results in different geological activities and formations. At divergent boundaries, plates move apart from each other, creating new crust. This process is known as seafloor spreading and is most commonly seen at mid-ocean ridges. At convergent boundaries, plates collide, forcing one plate to slide under the other in a process called subduction. This can lead to the formation of deep ocean trenches and volcanic arcs. Transform boundaries occur where plates slide past each other horizontally. The friction between the plates can cause earthquakes, as seen along the San Andreas Fault in California. These plate movements are responsible for many of Earth's most dramatic geological features. The constant motion and interaction of the plates shape the landscape, creating mountains, volcanoes, and triggering earthquakes. Mountain ranges are formed when plates collide and buckle. The immense pressure forces the Earth's crust to fold and rise, creating towering peaks like the Himalayas. Volcanoes erupt where magma rises to the surface at plate boundaries. The molten rock, or magma, is generated by the intense heat and pressure within the Earth and can create explosive eruptions. Earthquakes occur when plates suddenly slip past each other, releasing enormous amounts of energy. This energy travels through the Earth's crust as seismic waves, shaking the ground and causing destruction. Scientists study these tectonic activities to understand the past and predict future changes. By monitoring plate movements, they can forecast potential earthquakes and volcanic eruptions, helping to mitigate their impact on human life. The relentless forces of plate tectonics continue to shape our world, creating diverse landscapes and influencing the environment. From the highest mountains to the deepest ocean trenches, the story of our planet is written in the movements of its tectonic plates. Over hundreds of millions of years, the Earth's continents have come together and broken apart multiple times. One of the most recent supercontinents, and perhaps the most famous, was Pangea. Pangea, meaning all lands in Greek, formed gradually as the Earth's tectonic plates continued their slow, relentless dance. Around 300 million years ago, the continents we know today began to collide. Slowly but surely, they were drawn together by the movement of the tectonic plates. Over millions of years, these landmasses merged, eventually forming the massive supercontinent of Pangea. This process dramatically altered the Earth's geography, climate, and the life that inhabited it. Pangea was a world within a world. Its vast size created a wide range of environments, from lush rainforests to arid deserts. The climate varied greatly from the warm, humid tropics to the cold, dry polar regions. This diversity of habitats supported an incredible array of plant and animal life. The supercontinent was home to the ancestors of many of the plants and animals we know today. Early reptiles, including the ancestors of dinosaurs, roamed the land. Synapsids, the ancestors of mammals, also thrived during this time. The oceans teemed with a variety of marine life, including fish, ammonites, and early corals. Giants of Pangea, the reign of dinosaurs. This era marks one of the most fascinating and awe-inspiring periods in the history of our planet. The reign of the dinosaurs is perhaps the most iconic chapter in Pangea's history. These magnificent creatures dominated the land, sea, and air, leaving an indelible mark on the planet's evolutionary timeline. Dinosaurs first appeared in the Triassic period, around 230 million years ago, when Pangea was still forming. This supercontinent provided a vast and varied landscape for these early giants to explore and adapt to. They thrived on the supercontinent, evolving into a dazzling array of forms and sizes. From the small, agile coelophysis to the towering, long-necked sauropods, dinosaurs adapted to every niche and environment available. Some dinosaurs, like the mighty Brachiosaurus, were herbivores, feeding on the lush vegetation that covered much of Pangea. These gentle giants roamed the forests and plains, their long necks allowing them to reach the highest treetops. Others, like the fearsome Tyrannosaurus rex, were carnivores, hunting other dinosaurs and smaller animals. With their powerful jaws and sharp teeth, they were the apex predators of their time, instilling fear in all who crossed their path. Dinosaurs ruled the Earth for over 180 million years, their reign spanning from the Triassic to the end of the Cretaceous period. During this time, they witnessed the breakup of Pangea and adapted to the changing climates and landscapes, showcasing their incredible resilience and adaptability. The Great Pangea begins to break apart. The supercontinent of Pangea, despite its seemingly eternal presence, was not destined to last forever. The same forces that brought it together, the relentless movement of the Earth's tectonic plates, eventually tore it apart. Around 200 million years ago, cracks began to appear in Pangea's massive landmass. These cracks, driven by the diverging tectonic plates, widened into rifts, creating Gondwana and Laurasia separated by Tethys Sea. As the continents slowly drifted apart, the single global ocean that surrounded Pangea began to divide, forming the Atlantic Ocean and the Indian Ocean. This breakup had a profound impact on the Earth's geography, climate, and life. The breakup of Pangea was a slow and gradual process, unfolding over millions of years. As the continents continued to drift apart, they began to resemble the landmasses we know today. North and South America separated from Europe and Africa, opening the Atlantic Ocean wider. The Indian subcontinent broke away from Africa and drifted north, eventually colliding with Asia to form the Himalayan mountain range. Australia and Antarctica, once connected to each other and to South America, separated and drifted to their present-day locations. A glimpse into the future, the coming of Pangea Ultima. Imagine a world where the continents as we know them have shifted and merged into a single massive landmass. This is the vision of Pangea Ultima. The Earth's tectonic plates are always on the move, and their dance is far from over. These colossal slabs of rock, floating on the semi-fluid asthenosphere, are constantly shifting, colliding, and drifting apart. This movement is driven by the heat from the Earth's core, causing convection currents in the mantle. Scientists predict that in the distant future, millions of years from now, the continents will once again come together to form a new supercontinent. This process, known as the supercontinent cycle, has occurred several times in Earth's history, with Pangea being the most recent example. This future landmass is often referred to as Pangea Ultima. The name itself evokes a sense of finality, suggesting it could be the last supercontinent to form before the Earth's tectonic activity ceases. The formation of Pangea Ultima will have a dramatic impact on the Earth's climate and life. The merging of continents will disrupt existing climate patterns, leading to significant changes in temperature, precipitation, and wind patterns across the globe. The collision of continents will create massive mountain ranges, altering weather patterns and ocean currents. These new mountain ranges will act as barriers, influencing the flow of air masses and the distribution of rainfall. The interior of the supercontinent is likely to be arid and desert-like, while the coastal regions may experience more moderate climates. This stark contrast in climate conditions will have profound effects on the ecosystems and biodiversity of Pangea Ultima, shaping the evolution of life in ways we can only begin to imagine. The formation of Pangea Ultima will pose significant challenges for life on Earth. The changing climate and the merging of previously separated ecosystems will force species to adapt or face extinction. Some animals may thrive in the new environments, while others may struggle to survive. The merging of continents will also lead to the mixing of species that were previously isolated from each other. This could result in new competition for resources and the spread of diseases. However, it could also lead to the evolution of new and fascinating forms of life. The ever-changing Earth, a never-ending story. The story of Pangea, its formation, its breakup, and the eventual formation of Pangea Ultima is a testament to the dynamic nature of our planet. The Earth is constantly changing, its surface reshaped by the relentless forces of plate tectonics. These changes have shaped the course of life on Earth, driving evolution and creating the incredible diversity of species we see today. As we look to the future, we can be sure that the Earth will continue to change, offering both challenges and opportunities for life to adapt and evolve.